Hello again and welcome back to Project Planetree. This episode we're going to drop the rudder. Now I know you say, well, it's still there. Well, it's been held with a cinder block. I originally wasn't going to drop the rudder, but I took a look at the bearing at the top and it was carbon steel and it was really rusty. And the more I started to take things apart, the more rust I started finding. And I was thinking, now this thing may last 10 years for all I know, but the problem is I don't know. So I want something that'll last 50 years, not I don't know. Also, when I took loose the gudgeon at the bottom, I found out that they used a pressed-in cutlass bearing, which is a common practice, but that uses Buna-in, not a material that is a really long-lasting material like what we went back with. And this has been a pretty substantial technology upgrade too. At the top, we went back with stainless steel bearings, and here at the bottom, we went back with UHMW. And all the parts were custom built, made here at the boat farm. And let's take a look. The rust is gone, the bearing's gone, and we can now start making parts. Clearly, there's still a lot more to do in this space, but we'll do that later. Right now, let's focus on the pintle bearing. So, fortunate for me, I have access to an end mill. That makes it a lot easier because I have to cut through this old cutlass bearing, which consists of essentially a brass sleeve that has a buna-in wear surface. You gently have to cut through the material without going so far that you're actually cutting into the gudgeon. So what I usually do is just stop, when I'm cutting something like this, I'll stop a couple thousandths before I actually break through, and that's not enough to stop me from being able to take a chisel and knock it out. Difficult as this seems to be, I suspect that someone has used Loctite on this. So the best way to combat that is make sure that, of course, you cut as far as you can, and then apply some heat. Heat will help in two ways. It'll help expand and make that bearing or that cutlass bearing slide out a little easier, but also it'll soften whatever Loctite or adhesive that they may have used. The goal here isn't to heat it red hot or nothing like that. You only have to raise the temperature up to about 300-400 degrees, and anything that's in there is going to let loose. The nice thing about this UHMW is that it is relatively inexpensive. I bought this piece from eBay. You can't really see, this is actually a cutoff from a larger piece I bought. It was like 25 bucks for a foot long piece that was about 2.25 inches. I bought 2-inch piece, but it was slightly larger, so I had to turn it down on the OD and the ID as well. Happy to do that, because even if it was the right size, I wouldn't trust it. I'd want to turn it down. timing couldn't have been better for this little lathe. Paul rebuilt it this past winter, and ever since then, it has been really handy. Okay, so we have our bearing here. This is the new bearing. Interesting. So that's a stainless steel bearing. What was on there before was carbon steel. And interesting enough, it was something, they scribbled out and put 18. The 20618 is what I needed. So that's a little bit suspect. So I better check that out. Yeah, 1.1 inch. So it's right. They must have had the manufacturer was with the wrong box. I bought this off of eBay, and it saved me about $100 off the price of that bearing. So anyway, this was originally, you saw the bearing that I cut out. It was a 2-hole bearing, and now I'm going back with a 4-hole bearing. There's the 2 holes that the other one mounted to. And there's some slice marks that I left on it. Starting to get a little dark. I'm hoping all this shows up. There's a storm, a big storm rolling in right now. Yeah, so anyway, I don't really care so much if it's a 4-hole or 2-hole, but I didn't want to go back with carbon steel. I wanted to go back with stainless steel. And this is the same brand and type of bearing that I put on the drive shaft as well. So it is one size smaller because the rudder is 1.1 inch and my drive shaft's 1.25 inch. But I've used this bearing before on the project. And with the low RPM, these are typically used in food manufacturing plants and places like that. I don't really see a huge nautical or maritime presence, but I just don't like rust. You know, as the bottom line is this is a pretty substantial bearing. The rudder doesn't move that fast, and it's every bit of the quality of what came out of it. And also, when it comes to these guys, as you can see, they look pretty rough too. So I'm not going back with them. I mean, that is really, really bad. I could grind these clean, and reason they're wood. Yeah, 3/4 inch thick. Same with both of them. So yeah, that's 3/4 inch thick, and they're look to be about 8 by 8. Yeah, that's exactly what they are, 8 by 8. So they're 8 by 8 squares. I'm just going to replace them. I'm not going to use them. And what I'm going to replace them with is this sheet of stainless. Of course, I'm not using a whole sheet, but I'm going to cut me some 8 by 8 squares out of this stainless. I bought this off of Facebook. It was a gentleman, multi-generation machine shop, fab shop, closed. And when the liquidators came in, they were going to give him nothing for his steel. So he kept his steel, and he's selling it on Facebook, and it's pennies on the dollar. I bought a piece that was for the drive shaft that was a fraction of the size for this sheet here, and I paid twice as much. So really a good deal. And it's this piece is right at 1/4 inch. This edge here has been shear cut. They had a nice shear. I don't. I'll end up having to cut this with a bandsaw or sawzall. We have a plasma cutter here, but I don't know how to use it. I haven't learned how to use a plasma cutter yet. That's one of the things Paul was mentioning when I told him I got lucky and found out this guy with all this stainless stuff, because I bought a lot of it from him. He told me, he said, hey, listen, you have some scrap, we can practice. And yeah, we'll have lots of scrap. And that's one of the things I plan on getting used to is TIG. I can't TIG well, and I can't plasma cut. I can MIG and arc, how we can stick, you know, use an oxygen settling outfit, but I can't I mean, it can't be much to it. I just never have done it. So we'll see what we can do later. But I'm not going to practice on a nice sheet like this. I'm going to use the pieces. So let's take a look. A special event for me. Usually when I have a lot of holes to drill in 316 stainless, I'm going to burn up some bits. But I drilled a bunch of holes in these 1/4 inch plates of 316 and never burned up a single bit. And I chalked that up to this time I ran the frequency down really low. We have an inverter on that end mill there, and I ran the frequency down to 15 or 20 hertz. I mean, it's really slow. And also I use plenty of Tap Magic, not just that red stuff there, which is just used as a coolant. You have some smoke there, but that's not like typical. That's not what I'm talking about when I'm burning up a bit. It's not uncommon to have a little smoke. By the way, everything that you see that I've done here so far using these machine shop tools, I could have done using hand tools or a drill press. I'm using them mostly because they're available to me and they do a nicer job, but I have made most parts like this with just hand tools. So don't think that you have to have this stuff to make these parts. So here they are. Everything's done and ready. I have 2 plates here, just like I had before. There's the old bearing. There's the new bearing. It definitely turned out nice. It looks shiny. And it is polished. I polish all my stainless. I try to polish and also passivate. And maybe in another episode we'll talk about what passivation is and why it's necessary, even though we're using 316L stainless. Here's the rudder and the new bushing. And I had a video of me putting the bushing in, but I somehow messed it up and lost it when I was copying over my files. But all I did is, as you can see, I still have the stuff out. This black stuff that you see around here, that's just a coating of this. It's silicone gasket material is what I use. And you don't have to use that exact kind. The purpose of it is to make sure that if there was ever any shrinkage or something like that, that it couldn't possibly slide out, which would be impossible, and the rudder would have to come out before it to come out. So anyway, yeah, I put it in there. It fit nicely. I mean, you know, I have the mallet here, but it was a good press fit. It wasn't like I was worried about that. You know, they have clearances. You can go online and you can see what a rudder clearances should be, and it's usually measured in millimeters. You know, it's real sloppy, and the reason being is that you're using a hydroscopic material like Delrin or Buna-N, and those swell. This is UHMW. It does not swell. So you can go with very close tolerances and it will hold it. It will not change under the water. You don't want to go just slam up against it. You do want to leave some clearance, but I think I left a half a millimeter at the most. Anyway, that's it. It turned out really good going from that to that. And let's see, from that to that. It turned out pretty good. All right, well, we'll see you on next episode. So this is what Susanna does while I'm working on the boat out in the hot heat. Fan, air conditioning, book.
And phone.
Oh, that isn't a book, that's a phone. All right, same difference.